So I wanted to start just by saying how very happy I am that you are all here. And to you online, I'm very happy that you are all here too, because for a while I have been talking to all the other philosophers who would listen, saying I think we need to be paying a lot more attention to what's going on in deep learning right now. So I'm very pleased to see you all here, interested in these topics, and to the other speakers too, because if I were to organize a conference, this is exactly who I would want to see and exactly what I want to hear them talk about. And I didn't have to do any of the organizing. So thank you very much to Ned and Dave and Raphael. So, part of my pitch is that I think philosophers and computer scientists should be talking to one another a lot more, in particular in a historically grounded way. And in that line, I have a book hopefully coming out this summer, knocking on wood here, that tries to offer a philosophical framework for grounding that discussion. I'm going to give kind of the basic pitch for that today. But due to the time, I'm going to have to move through a lot of stuff really quickly. It's going to come out with Oxford, and they let you post the first chapter online. So I put that on my website. If I go too quickly, you want more details, you can go to Phil Archive or my website to read more. But the basic pitch for the framework that I'm offering in the book and in this talk is empiricist philosophy of mind, going all the way back to Aristotle, but especially Locke, Hume, and so on, is a great framework for grounding a discussion. I'm not the first to say this, but I worry that it's been a little bit misframed. It hasn't been framed in the most useful way. And so I'm trying to push it back and also give lots of off-roads, both to the philosophers to now understand all the different architectures that are out there in deep learning, what their philosophical relevance is, but also to the computer scientists, where they might jump into the historical literature or secondary literature on the historical figures to learn more. So a little rundown of the talk. I'm first going to kind of give what are the stakes of this debate, which I think is now framed, or another reincarnation of this long-standing debate between nativism and empiricism, now in the context of AI. I'm going to suggest a reframing of that debate from some of what we've seen in the last 5 years or so that I think is more useful. And then I'm going to pitch a particular strain of moderate empiricism that I think actually characterizes most of the research in deep learning that's maybe more charitable than some of the construals of empiricism that we've seen lately. And then I'm going to just give a little bit of advertisement for later chapters in the book to show, how much farther you can take this perspective and understanding other recent achievements in deep learning. So, like I said, major figures have already invoked the philosophical history here. I'm not like imposing this on them. So, in the AlphaZero paper, they mention the tabula rasa, and this is language that goes all the way back to Aristotle. The tabula rasa referring to the wax tablets that the Greek academies used to take notes, which could be blanked by reheating them, and that would make the wax clear so you could write on them again. And they want to say, we designed it to do this without any human knowledge built into it from the beginning. And Gary Marcus has also then targeted this claim in that paper. So, this is already very much at the forefront of the discussion of what should we be doing in deep learning? How do we interpret current achievements, and where should we go next? And particularly what's at issue is how much knowledge should we be building into these models from the beginning? What we have here is another incarnation of this very long-standing debate between sort of nature and nurture. It's basically, is human knowledge more the result of sort of interpreting the cipher of experience, or are we kind of unpacking an innate mental endowment to get the kinds of abstractions that make human cognition possible? And this is a grand dualism, like sort of many others, between good and evil, or reason and emotion, mortal and divine. And I think these dualisms have a very powerful attraction on the human intellect. They pop up again and again and again throughout the centuries in different forms. But they can also cause us to kind of oversimplify things and sometimes misinterpret one another's views. Sometimes you get opposing intuitions rubbed against each other in a way that's not very helpful. And you always need to carefully tend them. I compare these dualisms in the book to the discovery of a basic technology like fire, where now you can do things, you can formulate new hypotheses, new methods that maybe you couldn't without the dualism, but they also have sort of attendant dangers. The fire can burn out of control or generate a lot of smoke, lets you not see what's going on in the details. So we need to be careful. And I think philosophers have some experience tending to this particular fire. And there is some benefit. So, I know philosophers of science in the audience, especially those with a background in biology, might be going, oh no, here we go again, right? Nature and nurture, didn't we learn after decades of bitter disputes in biology that everything's really an interaction between environment and genes. Why do we need to do this again? But, you know, there have been some big success stories where this dualism has influenced some of the most important achievements of 20th century science. You know, Einstein, John Norton has this good paper about how Einstein's reading of Hume's empiricism sort of inspired his general theory of relativity, or special relativity, sorry. And Noam Chomsky famously invokes Descartes' nativism in his design of his linguistic theory. So there, you know, it's been very influential, and sometimes it's a very successful source of inspiration for theorists. So we shouldn't give up maybe too easily. We should see if we can reframe it in a more useful way to avoid the talking past that maybe occurred at sometimes in that debate in biology, for example. So really, I think what's going on here is there was this disagreement 2,500 years ago between Plato and his student Aristotle about the source of universalizable or generalizable knowledge, right? Plato thought that the sensory information was just too paltry, a starting point to get the kind of knowledge that we get that can generalize to future experiences is universalizable. And Aristotle, no, insisted that it has to somehow come from sensory experience. And we've never really recovered from this basic fight between teacher and student a long time ago. I'm not sure why the empiricists always look right and the rationalists always look left. I only had to flip one picture here, actually. And you know, Dave used a couple of the same pictures in his talk yesterday, so I'm not doctoring this. But it shows up, like I said, again and again and again in new incarnations in every century. And the current one is no exception. In the present incarnation, you know, a number of thinkers, here's Judea Pearl with an influential blog post he made worrying about a kind of radical empiricism capturing recent machine learning, deep learning research, according to which you can learn everything just from conditional probabilities in the data. In this influential BBS critical article by Lake, Ullman, Tenenbaum, and Gershman, they put a little more meat on the bones. They go back to Turing and say Turing had this kind of empiricist view that the mind had rather little mechanism and lots of blank sheets. And they tie this to echoing behaviorism, a dominant psychological tradition in Turing's time. And they say this view, the simplified behaviorist view, was repudiated by cognitive science, right? This is kind of standard sort of post-Chomskyan tale you get again and again and again, lots of different places. This is the narrative I kind of want to challenge, that that's really what's going on in deep learning today. What we could do, I think, instead, so instead of the timeless, unsolvable philosophical riddle, we could try to convert this into a testable empirical question, right? Namely, we have a set of methods that are inspired by nativist philosophy and a set of methods that are inspired by empiricist philosophy. We build bots according to those methods, and we just see which ones are most successful or human-like, right? So instead of being something that we need to resolve with a priori debate methods, we can treat it as a testable empirical question to be arbitrated with empirical methods to the winner go the spoils. And you can see all the good robots over here, so you know where I lie. Very quickly, just do some terminological stuff. What do we mean by innate and learned here? We could give a 3-hour lecture just on different approaches to innateness in philosophy. I'm not going to do that. I'm just going to do a citation dump instead and say, for present purposes, all I'm going to do is say innate means not learned. It's kind of minimalist view that's good enough for present purposes. That puts all the weight on what does learned mean. Here, again, I'm going to go minimalist just for time's sake. All we really need to mean here is anything that a parameterized neural network architecture trained by gradient descent end-to-end can do after training, which it couldn't do before. Again, you can write a whole dissertation in these waters if you want, but there's not time. So one way to give some grounding to the basic question is, what is the origin of abstract knowledge? For example, a particular example that was actually talked about at length in both the history of philosophy and in current cognitive science. What is the origin of the abstract idea of a triangle? Is it innate or derived from sensory experience? And the reason that this is a difficult thing to do, is when you're exposed to triangles, you see a lot of different triangles, right? They're idiosyncratic in their presentation of particular features. They have different angles, different sizes, different locations in the visual field, different angular orientations, and so on. And how do we abstract, the abstract general idea of a triangle that somehow is shared in common amongst all that idiosyncrasy? How do we do that? This is a question Locke raised directly in his essay. And I also want to, in generalizing to the current moment, ask what kind of empiricism should we attribute to deep learning? So is it like the simplified behaviorist view that we've seen in a couple places, or should it be something a little bit more subtle? And I think the historical empiricists here were indeed much more subtle. If we look to the critics, Steven Pinker has a famous book, The Blank Slate. He has a not entirely charitable view of what empiricism is in that book that a number of people have called out. He kind of dismisses it as being silly. Blank slates don't learn anything. You can throw any amount of stimulus you want at a, inert mineral slab. It's not going to learn anything. I think all major empiricists have recognized this. But Gary Marcus, more recently, Pinker was his mentor. He kind of tries to formalize this view a little bit better. And this is in his archive paper that I mentioned earlier. He says, one might think of cognition as a function over 4 variables, A, R, K, and E, where A is innate algorithms, R is innate representational formats, K is innate knowledge, and E is experience. And he says, the true blank slate would set K and R to 0, A to some extremely minimal value, and leave the rest to experience. And he says, this is the view that Locke articulated when he said all ideas come from sensation or reflection. Now, this was the part in reading this where I said, what is going on here? Because if you read even the next few pages of Locke, he talks about attention, imagination, the fancy, by which he means imagination. He talks about psychological faculties, right? So the overarching theme I'm going to try to correct here is that all of the major historical empiricists, were to one degree or another faculty psychologists. That is, they believed that the mind had a kind of cognitive architecture that allowed it to extract abstractions from experience. They appeal to these faculties again and again in their explanations of where we get particular abstract ideas like a triangle, for example, but also even more advancements like justice or goodness or whatever. So I think we should reframe this debate instead of is anything innate versus is something innate. That's not a useful frame. To one versus is what's innate domain specific or domain general, okay? So in particular, all of the historical empiricists, and I'm going to argue many current deep learning theorists assume that there are some rather rich domain general resources that can be built in from the beginning that are not learned by gradient descent. In particular, the architecture of the networks. Some people say that it should be learned also, but most people don't. They think you can take that for granted and that it roughly corresponds to some kind of brain structure, wiring motifs or whatever. Nativist philosophers Lawrence and Margolis, for what it's worth, so they're kind of on the other camp, they've also worried that this way of framing debates where current empiricism is just neo-behaviorism has the consequence that for some time there really aren't any empiricists, and maybe there never were. Maybe even the radical behaviorists had a more subtle view than this. This is something Quine even complained about explicitly quite a while ago, that even the radical behaviorists presume some innate structure. The debate, I think, should rather turn on whether domain-specific representations are acquired by specialized domain-specific systems or by domain general learning systems being repeatedly engaged. So like memory, attention, imagination being repeatedly engaged for lots of different domains. Memory, for example, being kind of a paradigm domain general resource in that it can perform its operation on sort of any type of content, whether it comes from perception or imagination or reflection, whatever. As the Stanford Encyclopedia entry on Locke puts it, while the mind might be a blank slate in regard to its content, it's plain that Locke thinks we're born with a variety of faculties to receive and abilities to manipulate or process that content once we acquire it. Thus, for example, the mind can engage in 3 different types of action, putting ideas together, which I'll talk about in a second. And in addition to these abilities, there are such faculties as memory, which allow for the storing of ideas. These things don't have to themselves be learned to take for granted. As an empiricist, a card-carrying empiricist. Here's just, an example of Hume's faculty taxonomy, for example, from a Hume scholar. You see familiar set of domain general faculties, memory, imagination, and so on. Now, to be charitable to the other side, I do think there is still space for a meaningful debate between 2 groups that disagree with one another, and both of which are empirically plausible. The most popular nativist option would be something like the core knowledge. I think this is very popular amongst critics of deep learning today, say we need to build a little bit more core knowledge into these systems in order to get them able to do intuitive physics, theory of mind, arithmetic, maybe some naive logic. And to do that, we need to build at least some small number of slightly domain-specific concepts into them from the beginning. So the moderately empiricist alternative that I want to articulate, that is not the radical behaviorist caricature, but the moderately empiricist alternative, is that we have domain general faculties governed by domain general inductive biases. It could be implemented via wiring motifs or architectural constraints, global parameters in the model, are sufficient to extract domain-specific abstractions from rich structured environmental input. Here's a few position papers from some major empiricists, deep learning researchers, some philosophers commenting on them, that I think you can get this gist from these position papers pretty explicitly. And by the way, they argue that abstractions that are extracted in this way, rather than being manually encoded, will be, in the end, more flexible to a larger number of situations. Here's an example of what some of those domain general inductive biases might look like from a position paper by Goyal and Bengio. A couple years ago, you get things like group equivariance from convolution operation, recurrency gives you equivariance over time, soft attention gives you equivariance over permutation, like in transformers and so on, right? These are all domain general, I think. It's the important part, why they're still empiricists. So I think if you do this reframing, as I suggest, you get a much more subtle continuum of views, right? Between sort of radical behaviorism on one end, radical empiricism on the other, but then most of what's empirically plausible is somewhere in the middle. And you have to think about, like, where do I fit on this continuum, where the line is at least something like how many domain specific concepts or learning systems do I need to put in the beginning to get human-like cognition? And how much do I think is going to come from experience? I've shaded this area here because I think this is the part that's still empirically plausible. We've learned a lot. And I think empiricists have basically won most of the field, I will say, compared to, you know, like original government and binding Chomsky, where you have potentially hundreds of principles and parameters, or, you know, Plato thinking basically every simple concept is innate from the forms. I think this is the area between, like, maybe core knowledge being sort of the most nativist option that's still empirically plausible, and then maybe some version of Locke, or, you know, something a little bit further to the left of that being the most option that's still empirically plausible for empiricism. So interim summary before I start getting into some specifics. Why is the history of philosophy here potentially important, both to computer scientists and philosophers interested in the state of the art? The question of nativism versus empiricism is seen as having crucial consequences in engineering methodology, right? In particular, should we manually program core knowledge systems into intelligent agents, usually using things like rules and symbols in a classical or hybrid system? Or should we enable them to learn the domain-specific abstractions themselves through the use of domain general inductive biases, implemented being architectures or whatever? But this connection is not being drawn in the most productive way. So far, deep learning channels the historical empiricists, not the psychological behaviorists. And deep learning engineers might continue to mine gems from the history of philosophy, especially for more general cognitive architecture and more systematically rational decision-making. Like I say, if you read the first few pages of Russell and Norvig's, you know, AI Bible, they give a paragraph from Aristotle in the first few pages, right? And they say, look at this. You can sort of read an algorithm for rational planning out of what Aristotle said. I think you can do that dozens of places in the history of philosophy. And I'm going to give you a couple more examples today. And I don't think that's a coincidence. Like I said, I think the problem space of historical empiricist philosophy is the same problem space that deep learning engineers are working in today. I actually think if Locke or Hume were alive today, they would just feel like kids in a candy store with everything that they can say. That we knew the mind did this, but we had no idea how. And now you have some mechanisms that can do that. Isn't that great? So philosophers in particular can dispel magic from classical empiricist accounts. Locke and Hume repeatedly got savaged by their commentators, you know, where they would do this thing. Hume in particular would do this thing where he says, look, I know the imagination does this thing, but I have no idea how to explain it. I'll give you the evidence that it does it. But there, I'm just going to step back because I'm going beyond what I could say responsibly. You know, a modern cognitive psychologist might think that's a responsible thing to do, but the commentators at the time savaged him for just sort of wishful thinking, Hail Mary passes. But now, you know, we might finally, it's a really exciting time to be interested in empiricist philosophy and be following deep learning, because it looks like for the first time, we have some systems that can actually do these things that they were just speculating about. Isn't that great? So returning to this question, okay, specific example, how do we get the innate idea of a triangle? This is something that deep convolutional neural networks of the sort that like LeCun and others were so influential in developing could do pretty well, right? And you do it by having a stack. Again, I'm not going to get into any of the mathematical details, point you to other publications like this Phil Compass piece I talked about here, where you stack a number of different operations in a kind of deep hierarchy, convolution and pooling in particular. And by the end of it, you get a kind of transformed input signal that you can pretty well classify pretty abstract types of objects at, and it has performance at, you know, human or maybe even superhuman levels of accuracy. One thing I want to clarify before I start talking about the relevance of what like a deep convolutional neural network does to what humans and animals do is a question of whether they're really intelligent or really agents versus modeling intelligence or agency. I think a modeling language is a little bit more useful, at least for now. So what does the success of these models teach us about intelligence, cognition, or rationality? I think current models are likely, and this should be kind of obvious, they're only slivers of rational agents, right? They're kind of parts of rational agents, I think. They're relevant. They're not nothing. They really are modeling real aspects, different making aspects of these systems. But they're obviously not a full rational agent for some of the reasons that came out in the debate yesterday. So I think this is helpful to remind in the beginning, it's a separate question, which aspects ground the moral, social, political, or existential value of rational agency. And we need to do some additional philosophy to figure out, are the aspects that we modeled in these systems so far the important ones? That's a separate philosophical task. One way you could try to make sense of the relationship between these models and what the mind does, Catherine Stinson, who I saw here earlier, we'll talk to her later, has this view that there's maybe a kind of generic mechanistic kind. That is a kind of abstract mechanistic structure that's shared between some of these models and maybe the mind or brain. DiCarlo and Yamans, for example, have claimed that a deep convolutional neural network and the ventral stream processing in the perceptual parts of the brain share what they call a linear nonlinear decoder mechanism that's kind of pitched at the right level of abstraction to explain how both of these systems do the job of controlling for that sort of nuisance variation in, say, recognizing triangles that I talked about earlier. I asked Rosa if she was going to talk about this, but Rosa also has a good paper with Dan, sort of giving an even more technically subtle version of this sort of view that you could define the similarity between the model and the target system using precise behavioral decoding measures and transform similarity metrics. And I will forward all questions about that to Rosa. She said she's probably not going to talk about it. You can ask her about it later. So you can make this sense of aspects very precise if you want in one way or another. And if, I'm not using aspects as a hedge word. Gualtiero Piccinini has a recent book where he, goes on to the metaphysics of aspects for several chapters. You can really do high church metaphysics with it. So if you want, it's a technical word. I recommend these other resources. But what are the aspects then in this particular case for deep convolutional neural networks that are now quite successful at category recognition object detection? I think, again, this is the case. Empiricist philosophy of mind gives us a really good framework for understanding what those different making aspects are and also making them intelligible to non-specialists. And I think this is really important because these networks are now everywhere, right? They're doing all kinds of things and people want to know, what are they doing? What does this have to do with what I do when I recognize objects? And I think empiricist philosophy of mind is a great resource here. So if we go to Locke and we ask, okay, so how do we recognize the abstract idea of a triangle? He gives us a few different methods of abstraction. So the first you can call, following Chris Gawker, abstraction as subtraction. So that's like you put together a bunch of triangles with all their idiosyncrasies and you just subtract out the ways that they differ from one another. And whatever's left is the abstract idea of a triangle. Okay, that's one method of abstraction Locke talks about. Another method Locke talks about is now you start with abstract components. You start with like the abstract notion of a line, the abstract notion of an angle, maybe the abstract notion of three, and you put those abstract concepts together in the right way to get a more abstract concept, right? So, the dotted here indicates these are already a little abstract, and you put them together in the right way to get a more abstract concept. That's another method Locke talks about. Another method Locke talks about is called abstraction as representation. And that's where you don't actually really do any abstraction, leaving out or assembling that way. You just use one particular example to kind of stand in for the rest of the class, right? And this was favored by Berkeley and Hume when they were kind of criticizing Locke for the earlier two methods. And there's another method that you can pull in particular out of Hume that's maybe most useful for things like mathematics, logic, the most abstract domains. I call it abstraction as invariance. And that's where you try to figure properties that are conserved across some systematic set of transformations or permutations, right? You kind of try to do these transformations or permutations at the limit, and whatever's left is the abstract property. Noether's theorems in physics, for example, are an example of abstraction as invariance. And so here's some citations if you want to get further into that. What I think is particularly interesting in understanding the relationship between deep learning and philosophy here is that the history of philosophy often treated these methods of abstraction as competitors, right? Like we got to figure out which is the right one, or, you know, argue against one to make a case for the other. But one thing that I think that's cool is that if you look at deep convolutional neural networks, they really have components that do at least three of these things. Okay, at least abstraction as subtraction, abstraction as composition, and abstraction as invariance. So the convolution operation, one thing I argue, is that it kind of does abstraction as composition, right? It's a filter that is a feature detector. It builds more complex features using the weighting convolution operation from simpler features that it gets at the previous layer, right? Very much like Locke described. The max pooling operation, right? So, you know, if you're doing letter recognition, it's a figure I made to kind of visualize one particular application of this for like word recognition, is the max pooling operation. You could have, say, different ways of detecting a feature like a B at a lower level, right? And the max pooling node only fires if one of those potential ways of doing a B goes above a certain threshold. And then it passes that information that one kind of B was detected about here in the input. It's a little more resistant to the nuisance variation, the different ways that you could write Bs, right? And that's kind of like abstraction as subtraction, right? You're leaving out some of the details or minimizing some of the idiosyncrasies at the previous layer to say they were different ways of detecting a more abstract feature. And you can keep going. So every abstract feature that you build at an early layer can be reused again and again and again. And it becomes more and more and more abstract as you go up the hierarchy. Okay, you're not really going to the full limit the way you would want to for full abstraction as invariance. But the deeper the network, the closer it can approximate one of those limits. It becomes more and more controlling for nuisance variation. I think this is why deep convolutional neural networks are so efficient at the things that they do. It's very consistent with what like Yeomans and DiCarlo and Fukushima and Kuhn have said about why these networks work. So what is the basic tenet of empiricism? A lot of people go to Hume's copy principle to kind of justify the simplistic view. All our simple ideas are in their first appearance derived from simple sensory impressions, which are exactly correspondent to them and which they exactly represent. And you might read this in that kind of really restrictive way, saying, oh gosh, well, everything's got to just be a duplicate of some sensory impression. And that's all the mind can do with these things. And they kind of concatenate them with one another and so on. And he certainly gets read this way a lot, even by philosophers. But there's a lot of textual evidence that he all along allowed for more than rote reproduction with the copy principle. So for example, when talking about a faculty, the imagination, he says, nothing is more free than the imagination of man. And though it cannot exceed the original stock of ideas, furnished by the senses, it has unlimited power of mixing, compounding, separating, and dividing these ideas in all the varieties of fiction and vision. That sounds pretty permissive about what's going to count as being an approach to empiricism here. I think Tomas Demeter has a great paper here where he specifically rebuts Fodor's rather restrictive reading of Hume in these passages. Hume's often interpreted here as wanting to be like the Newton of the mind, to give us a kind of basic set of physical laws governing how mental representations interact with one another to produce rational behavior. And you get this picture of like ideas are like kind of billiard balls bumping into each other the way like basic physical objects would be. But Demeter argues the better model is like mental chemistry for Hume, where the thought is the imagination is like a laboratory where you can combine different ideas and you can maybe get a new compound that has properties that aren't just the sum of the parts. They're not just bumping into each other, but really forming new things. So I suggest the basic tenet should be something more like the transformation principle. The mind's simple concepts or conceptions are derived from systematic domain general transformations of sensory impressions. And those transformations can have domain general inductive biases built into them of the sort that you saw in that Guayao eventually. So I know there's a bunch of generic criticism. So, you know, take yourself back to 2016 or 2017, if you can, when we were thinking, gosh, our deep convolutional neural network's going to be AGI, right? And there were a bunch of criticisms. Well, no, obviously not, because there's a bunch of things that are wrong with them. They're very sample inefficient. They're brittle and subject to adversarial examples. You know, the panda given. They're opaque in terms of what features are learned. They have difficulty transferring, as well as humans, to very different types of stimuli. They have difficulty distinguishing correlation from causation, for example. I know all that. I'm not going to engage with any of these specifically. I'm rather going to paint a strategy for answering some of these criticisms in future research. And the strategy is, all of the historical empiricists worried about these things too in their own historically situated way. And they had some really sophisticated ideas about how to address them with domain general faculties. Maybe look at that if you're interested. So in particular, I want to say, yeah, DCNNs on their own shouldn't be taken as models of full rational agency. They're rather models of early vision, right? And they're pretty good models of early vision. They get some of the key difference-making aspects, but that's all they do. To get, a full model of the rational agent, we need to build more of that cognitive architecture back in with other types of parameterized domain general neural network modules. So rationality, needs to be characterized by a greater degree of flexibility, efficiency, insight, creativity, and control, and faculties can help with that. So this is, the picture, much like this one that LeCun showed yesterday, is a great example of this general approach to empiricism that I'm saying is characterizing most of the headline achievements in deep learning these days. So this is the rest of the chapters of the book. It has a kind of philosopher of the week style, where each chapter focuses on a faculty and an empiricist philosopher who had a particularly interesting and useful theory of that faculty. And then I show how some of the most ambitious speculations they had about that faculty are already implemented or maybe could soon be implemented in some particular neural network architecture. And again, this is kind of how I help philosophers digest all of these different architectures, is by tying them to like, this is kind of like the imagination. This is kind of like attention. This is kind of like memory. And I call this strategy, tongue in cheek, the new empiricist dogma, where dogma is the acronym. You got to have an acronym for computer scientists to take you seriously. Domain General Modular Architecture for cognition. But it's also like a sword of Damocles, right? It shouldn't actually become a dogma, right? We should only keep defending this insofar as it is useful and continues to deliver results and is empirically plausible. So what could the faculties do to help with these problems, for example? Well, memory could replay successful experience trajectories for offline learning and rapid consequence-sensitive decision-making. Imagination could help us compose novel ideas and experiences, engage in offline simulated learning, and choose on the basis of imagined future or counterfactual possibilities. Attention could help us have more efficient and selective processing of input, binding features together into wholes, approximating variable role binding operations, solving coordination and control problems across modules, predictive modeling and anticipation of an attention's target. Sympathy could help us imaginatively simulate others' perspectives for more mature social and moral decision making. And there's just a ton of great stuff in the empiricist philosophers about all of this. This is me slightly translating it into more machine learning friendly terms, but there's lots of great stuff. Also interest, passion, reflection. Well, I don't even get into those in the book, but you could write lots of great stuff about those too. So give some quick examples. Ibn Sina, who Dave mentioned yesterday, had a really cool theory of memory. So his starting point was Aristotle's battle metaphor of abstraction, which is really the first statement of an empiricist theory of abstraction, but it's just a metaphor. People have been having a hard time making sense of it for millennia. He gives this metaphor. It's like a rout in a battle when sensory experience comes at you. It's just rushing at you and your line breaks, right? But then you make a stand and one stand and another stand until you repair the front of the line. And by then you've got the universal. Okay, that's cool. But like, what on earth does that mean? And Ibn Sina saw that. He tried to fill in a lot of the gaps there. Okay. So how does that actually work? He fills in the gaps with a kind of hierarchical cascade of inner senses. It was based, he dissected some corpses. He knew a little bit about the brain. It's based on this theory of the ventricles, these fluid-filled cavities in the brain. We now know that theory is nonsense. But the functional part of it was quite sophisticated. Kemp and Fletcher, some historians of psychology, have this nice paper where they talk about how well Ibn Sina's theory of the inner senses fits with 20th century cognitive psychology and some of the hierarchical processing views that are popular there, where you have kind of inner association trading zones here, and then they get kind of assigned with reinforcement value here, and then finally stored in the kind of the abstracted memory gets stored in a final storehouse at the end of the process. And one thing that both Aristotle and Ibn Sina were adamant about here, and it's very interesting to me from a modern perspective, is that you didn't even have the kind of data that was worthy of being abstracted from until you had memory, right? Until many particular exposures to the same stimulus had already been abstracted and sort of collated by a faculty of memory. And one of the reasons Ibn Sina in particular was adamant about that is he thought you needed the affective value of the situation to be kind of encoded in the memory. for it to be useful for offline decision making and rational decision procedures. So I compare that approach to memory in rational choice to the DQN architecture from DeepMind. This is one that was used to play Atari games. I'll show you the picture real quick of the architecture. So you have a Q network, don't worry about the details, but it's learning a value for performing certain actions in a particular gameplay scenario directly from the pixels on the gameplay screen, right? And it's got a kind of convolutional neural network structure. You've got a decision procedure, but crucially, you've also got an experience buffer here, okay? So the way it works is you have hierarchical abstraction from gameplay input screens, associate reward values with abstract game features, and use this in adaptive, consequence-sensitive decision-making. And the experience replay buffer allows the network to be much more efficient in its learning because it can repeatedly replay sequences of gameplay actions in an interleaved way that provides efficiency benefits and helps avoid catastrophic interference. There's a long story in the history of connectionism there about the dangers of catastrophic interference. The explicit episodic controller buffer can be added that reintroduces a lookup buffer for much more rapid decision making. So this allows like one-shot learning. In other words, the buffer now can be used as also as a kind of lookup table where you say, I haven't had much experience in this type of situation, but the last time I did this thing in exactly this circumstance, it was successful. So maybe I just do that instead of trying to consult my Q values from the abstraction process, which takes a lot more samples. And crucially, the memory module here stores the Q values, that is the reinforcement value, with the abstracted situation representations. This is very much like what Ibn Sina insisted on, thousands of years ago. So, if you look, what gets stored here are 4 tuples. This is the abstracted situation representation. This is the action that was performed. And this is the reinforcement value from the Q learning network. And this is the next abstracted situation, what happens at the next time step as a result, just like Ibn Sina said. So, halfway joking here, but you can really plug in the various components of this network into Ibn Sina's abstraction workflow, and it works pretty well. And he has a lot of other interesting things to say about how it works. So that's one example. Hume also had a beautiful theory of the imagination that often gets overlooked or just misinterpreted. Fodor is even kind of completely stymied by this, as I'll show you in a second. Hume's raw materials for furnishing the mind start with the 3 principles of association. This is what Fodor, for example, in reading Hume, pays the most attention to. So the thought is you're supposed to get everything from the principles of contiguity, resemblance, and causality. That is, precedence. And Fodor raises these problems for Hume's associationism. He says it'll have difficulty synthesizing instances of abstract categories for use in reasoning, composing novel or fictional ideas. Hume actually himself in the treatise talks about composing the idea of a unicorn. You've never seen that. How do you get it? Or the New Jerusalem with streets of gold and walls of rubies. Where does that come from? I've never seen that in my experience. How do I do it? And he says also has difficulty decision-making in novel contexts, say based on planning. So Fodor complains in the Hume Variations book, where he sort of engages with Hume over a long period of time, that Hume solves all of these problems by appealing to the imagination. And he says it's cheating for an associationist to appeal to non-associative faculties. That, I think, is just the misreading of empiricism all along. But you can see how his reading of empiricists as psychological behaviorists is kind of interfering with his ability to get what's going on. By the end of the book, he eventually concedes it. By chapter 4 of Hume Variations, he eventually is like, okay, yeah, Hume gets the imagination, but he still doesn't explain how it works, right? So he still says, like I said, Hume kind of begs off in a few places. I have no idea how the imagination actually does this. I just know that it does. Here's the evidence. So I think now today, you've been playing with GANs, you've been playing with DALL-E 2. Like generating novel exemplars comes like pretty cheap now, right? And in fact, I think some of these models, the way they work, are quite similar to Hume's ideas. I talk about this a little bit in the 2018 Synthèse paper. It's kind of like the process of transformational abstraction in reverse in a GAN. What you get is a kind of specification hierarchy in the generative network, and I won't go into the details again for time, but it goes from a very abstract latent space code, gradually filling in details, kind of doing the inverse operations, they call them deconvolution and unpooling, to go in the other direction. In other words, transform it from a more abstract to a more specific representation. And you can generate as many specific exemplars as you want doing that. We've also learned that you can do some quite sophisticated composition using methods of vector interpolation. So this is, an ancient paper by deep learning standards today. But they found that if you took the vector from man with glasses, you subtracted the vector of man, and you added in the vector of woman, you could get a pretty good set of exemplars of women with glasses, even though the training set contained no women with glasses. And that was pretty cool. There were limitations to this, though. So in particular, David Watson in this paper complains, but it's not a real compositional understanding of the sort that Fodor wants of the visual scene. Because, for example, it takes this picture of Kim Kardashian and thinks, if you rotate the visual features around, it still says this is 100% Kim Kardashian, just like this one. Okay, if you were forced to pick a label, it's still 100% more Kim Kardashian than it is any other figure. But leave that aside. I think there's subtle points about what are we comparing to what in the evaluation here. But granted, it seems like deep convolutional neural networks don't make a firm distinction between like what is the exact compositional relations between the features. Maybe it just got lucky, for example, that sunglasses appeared in about that place in every picture. So when it sticks sunglasses on, they just get lucky being in the right spot. But you can do more with this, and especially by adding transformers. And I think this is a general theme of the DoGMA, is that you address the computational limitations of one type of deep neural network architecture with the computational strength of another type of architecture and vice versa. If you add in a transformer, which again, I won't explain, but they are very good at detecting long distance relations. That's why they work for language. You can get some of these compositional relations. So in particular, I like this Taming Transformers paper to make this point. They kind of add a transformer in the middle of the GAN composure process where the CNN encoder picks out the abstract features that occur in particular locations in the input image. And the transformer learns the long distance relations amongst them in this kind of quantized code book. And it learns them just like it would grammatical relations in a sentence. It doesn't care, like LeCun was saying yesterday. He actually talked about this type of architecture. It doesn't care that it's operating on features in a 2D array versus words in a long sequence. It's able to compose long distance relations in the same way. Then you pass that quantized relation that's been transformed by the transformer to the generator. And now it gets those relations right, by and large. That's one of the things that's improved the results, at least at some intermediate stage of this technology. They say, our key insight is to obtain an effective and expressive models that taken together, convolutional and transformer architectures can model the compositional nature of our visual world. We use a convolutional approach to efficiently learn a codebook of context-rich visual parts and subsequently learn a model of their global compositions using the transformer. So, I think this is a great example of the DoGMA in action. We use different general modules to kind of address the computational limitations of one another. Even cooler, you can use generative methods like in DeepMind's imagination augmented agents model to do consequence sensitive planning and future decision making. So they use this to play the Sokoban game, for example, which was very difficult to master with the previous reinforcement training DQN network that I mentioned earlier. Because if you put one of these, you're supposed to put all the crates on the dots, right? And if you get a crate in the corner, it's stuck, right? And you never get a reinforcement value, in other words. So it was very difficult for reinforcement learning methods to get any traction on this game compared to a lot of the other games that it was really good at. It seems like you need to plan out, 5, 10, 15 moves in advance before you start doing anything to make sure you're not going to get stuck and not get any reinforcement value. And this network, in fact, can do this. I'll give you like the 20-second spiel on it. It has a set of rollout encoders that are kind of mini generative models themselves, where they imagine what actions could I do in this case, and they explicitly call them imagination cores and compare them to the human imagination. And then what would be the result in the environment of doing that action? And then you just do a bunch of sequences of those, right? Okay, action, result, action, result, action, result, action, result. And it builds that rollout before it even makes a decision. For what it's worth, again, read the chapter when it comes out. You could almost read this algorithm out of Hume, for what it's worth. He has a very similar story about how you do planning on an empiricist perspective by kind of melding together forward models, forward predictions of what's going to happen as a result of your actions, and kind of compressing them together based on how often did I achieve my goal in various circumstances. That makes, he says something like, ideas vivacious in proportion to the degree to which I satisfy my desires in this situation, and that's how I make a choice. Again, just another example of something that fits really well. I use William James for attention, which I think is in many ways the most interesting faculty. And here we start to get to some places where I think the historical empiricists are still out in front of what we've been able to do so far in deep learning. So this might be a place where machine learning researchers could still get some inspiration from the historical empiricists. James says attention consists of two things: organic adjustment and ideational preparation, the latter one being the interesting bit. The accommodation part is just the adjustment of the sensory organs, moving your head, eyes, pupil dilation, and so on. Won't say much about that. But the second part is the cool part. That's anticipatory preparation from within the ideational centers concerned with the object to which attention is paid. I'll unpack that a little bit for you. So he says this is a modification of the imagination. It's imagination attempting to guess what will be kind of in the attentional spotlight before it's shined there. So he has all these discussions of like peripheral vision. What is it to attend to something in your peripheral vision? It's nothing more than the attempt to form the clearest picture in your mind of what you would see if you were to direct your eyes there before you do. And that forward model accentuates processing in all the ways that cognitive psychology associates with attention by, for example, making it more vivacious, making you more sensitive to divergences between your expectation and reality, and so on. Very predictive processing type view of what attention's doing as we describe it today. You form, as he says, an imaginary duplicate of the object in the mind, which shall stand ready to receive the outward impression as if in a matrix. It's a cliche in psychology that James is prescient, but James is prescient. You might have heard of Grace Lindsay. She has a great overview paper of different ways that attention has already been implemented in deep learning more generally. Mentioned very briefly a couple ways. Region proposal boxes can be seen as a kind of attention where you kind of mark up the image with places where an object is especially likely to appear, and then you focus more processing there. It makes the process much more efficient. You get accuracy gains too. You could also do salience mapping, right, where you kind of reweight a place where important features are very likely to appear. That's kind of like a soft feature attention that can be like enhancing the vivacity of what you're processing in historical empiricist terms. What about transformers? Obviously, the one that most people are talking about today. Their key innovation was the self-attention mechanism, right, that allows you to pay attention to reweight the current prediction of the next word according to words that might have appeared quite distantly in the previous context. They operate using this multi-head self-attention mechanism. This is a proprietary operation, maybe least like biological attention, at least in the brain. Raphael and I made a pact before the conference that we weren't going to try to explain it. So honoring my pact, we'll see if he does. I'm not going to. I'll just point you to Anthropic AI's analysis of transformers. And Jay Alamar has a bunch of great GIFs trying to help you understand how attention works here. I'll just point you to that. The quick thing that I want to emphasize, and this is where James is still ahead, I think, of the state of the art in deep learning, is that I think, disagreeing now with LeCun, I'm really scared to do that because, he's a big figure, but I think transformers will probably be around here to stay. We're just going to use them more modestly. We're going to stop thinking that they need to be the whole rational architecture themselves. I think they would be super useful for inner speech, though, to play some of those predictive modeling roles that James ascribes to the attention, right? So, you might worry the attention doesn't have goals and it doesn't have a really coherent world model and it doesn't satisfy multiple constraints simultaneously, flexibly in the world. But if you just had a kind of train of thought that was unfolding and it was driving and coordinating a bunch of other modules to produce forward models, to produce actions, and it was in turn getting, say, reinforcement type learning back from how successful all the other modules were at doing their work, that's a whole different game. Now transformers don't have to do everything on their own. They're just one part of a bigger architecture with lots of other modules that, again, fill in some of the computational gaps that are difficult for transformers to do. And I'm not the first to have this idea. There's a couple other papers. Google Robotics has this paper they call Inner Monologue for Robots that is one implementation of this idea. And there's a group in France, the Flowers group, that's very much in favor. They call them Vygotskian agents. I'm excited about that idea. Now, finally, getting out almost entirely ahead of the cutting edge of deep learning, I think, are the sentimentalists in the empiricist tradition, who their take on moral and social cognition emphasize the moral sentiments, which is what they took to be innate in this part. So in particular there, I focused on Adam Smith and Sophie de Grouchy, who was a commentator on Adam Smith and wrote a long series of letters elaborating her take on his view. And I think this points to a surprisingly promising dogmatic research program in social and moral cognition. So their take was that, or this is my take, I think social cognition and deep learning is in danger of taking on board too many kind of rationalist, Machiavellian or nativist assumptions about the structure of social reasoning in particular, starting with epistemic theory of mind, like false belief attribution as being the primary goal. I really think that's just a tiny part of social and moral cognition. And we need to focus on a lot of other stuff, especially understanding others' affects, understanding others' goals. That's going to be a lot. That's going to be the foundation. And then maybe we get false belief attribution much later when a bunch of other stuff is online. I think we need to do a lot more foundational work first. Smith argues in the theory of moral sentiments that the heart of moral and social reasoning is a kind of sympathetic simulation from various points of view, which eventually allows us to reach an impartial observer perspective. So the idea is like, you know, kids get angry, kids get scared, and they are taught by their caregivers and their peers that there are certain cases where it's appropriate to exhibit this emotion on the basis of situational factors, and certain cases where it's inappropriate, right? And you get enough of that learning and also observing other agents getting feedback about when they exhibit their passions. You eventually achieve a kind of impartial observer perspective in your culture where, you know, you would be justified, in other words, in being angry. You'd be justified in saying, this is unfair to me, that kind of. So this view, there's some great papers by Sarah Songorian. Fiery Cushman talks about this a little bit in his BBS paper. Julia Haas has some great reinforcement learning papers at DeepMind recently. This view has many advantages in a world of two systems accounts of social cognition because it can translate material from the particularist effective system and the impartial fairness system in a way that's compatible with reinforcement learning-based approaches. So I'm getting the stop sign, so this is the last slide anyway. But de Grouchy takes, one reason I like her view in particular is that she takes reflective sentimentalism down to the earliest reciprocal effective interactions between a newborn and a caregiver. She was a mother, and she said Smith starts way too late in development, right? She starts where you're already doing some, you know, pretty sophisticated abstract reasoning. One of the things that was very difficult in the history of moral theory was how do we bridge this self-other gap? In other words, from selfish solipsistic egoism to rational regard for the value of others, you know, the sort you get in like Kantian morality. And this is one of the reasons why I'm so passionate about de Grouchy is she said, look, you start to care about others at a very basic effective level before you even have developed a representation of the self, right? Infants learn that what happens to their caregiver matters to them and vice versa before they even represent themselves as being different from their caregivers. And I think this is a super cool view. And so like, from that perspective, rational egoism is like the aberration. That's the theoretically motivated view in the normal course of development. So this would suggest that future progress in deep learning in this direction should focus on controlled rearing and curriculum learning that's more like the stages through which children learn to develop this, say, impartial observer perspective, to render effective responses robust to what you might think of as social nuisance variables, very much like the visual nuisance variables that happen in visual tasks. Okay, so takeaways, enough already with the association of straw persons. Somebody tells you deep learning is just Skinner again, don't listen to them, tell them to stop. All empiricists get active domain general faculties. The dominant view amongst most prominent DL researchers today is what I've called the new empiricist dogma. Architecture should be composed of trainable parameterized modules, implementing domain general inductive biases and performing roles attributed to domain general faculties to extract domain-specific abstractions. And empiricist DNN researchers might start thinking more systematically about how these faculties function and can be integrated together into a coherent cognitive architecture. I don't think we've seen this yet, the way we did with like SOAR and ACT-R in previous incarnations of AI. And by the way, many empiricist philosophers thought long and hard about this. Take a dive. Thank you. If you want those backgrounds I skipped over, there's places to look.